In this question number 15, a charged particle Q is moving in presence of a magnetic field B, which is inclined to an angle 30 degree with the direction of motion of the particle. Draw the trajectory followed by the particle in the presence of the field and explain how the particle describes its path. So let us first draw the figure and try to understand what it is trying to say. So here in this particular case, uh, this is what the case. This is there is a charged particle, that charged particle having charge q, and this is moving along x-axis. Okay, the charge particle is moving along x-axis. Okay. And this is the magnetic field B. This is the magnetic field B, which is making some angle 30 degree with the direction of motion. Okay. And so as this charge particle magnetic here, this magnetic field will be having two components. Here it will be, or you can see that velocity. We can resolve the velocity of the charge particle. One component of this velocity will be along the magnetic field. Yes. So what will be that component? That will be cos 30 degree, and another component will be what? It will be perpendicular to that one. Okay. So it will be sine 30 degree. Okay. So velocity will be having two components. So due to this perpendicular component, what will happen? This charge particle will undergo circular motion here, and due to this horizontal component, it will undergo linear motion here. Vertical vertical component responsible for circular motion, circular and horizontal component responsible for linear motion here. So as there is both components are present, so when so here in this particular case, it will move um, move it will move in helical path. Here helical path is what? It is combination of linear plus circular. So it will move in a helical path. Clear? So what it is saying, draw the trajectory followed by the particle in the presence of the field and explain how the particle describes the path. So this is how it describes the path. That means due to one component, due to horizontal component along the direction of magnetic field, you can say it will undergo uh, linear motion, because due to as this component as due to this particular component of velocity, what I can say, force, there will not be there will not be any kind of force on this charge particle. So move undeviated. So move with this speed, because force due to magnetic field will not be acting upon it. But due to this vertical component, what will happen? There will be a force acting upon this charge particle, and due to which what it will try to do, it will try to uh, make it in circular motion. Here, so it will try to make circular motion due to this component, as we can see over here. It will it will move something in helical path. So how it will move path? Let us try to draw the figure first. Figure wise, it will be, so as this vertical component is there, and this is the direction of magnetic field. So what will the direction of force? Assuming this it to be a positively charged particle, the force acting on this charged particle will be outward. Here force will be outward. That means it will due to this component only, will try to undergo a circular motion here, but as linear component is there. Okay, so some linear motion will be there. Clear? So that means it will move in a helical path. Helical, what is how to show that helical path? Now let me draw it once again. So it will move in circular motion. Helical motion is like this. Let me draw the path first. So this motion will be something like this. Will move like this, like this. Okay. So this is some kind of motions. Force, direction of force is outward. So first of all, come out, 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 helical path. Clear. So this is how it will trajectory.